to the 5th lecture. I've uploaded the first 4 lectures on the YouTube channel, so you can view those there as well. What did we do last time? याद है किसी को? मेन थीम क्या था last time? पूरा हफ्ता गुजर गया.
शिफ्टिंग्स कर रहे थे, टाइम शिफ्टिंग कर रहे थे.
Time shifting, okay. Yes, time shifting. What other things? So, what was the broader topic that time shifting falls in?
Operations on
Signal operations, right? So, we need to do a lot of operations on signals to get different kind of information from them, or to, let's say, view them differently. Same information, but you want to view it a bit differently. So the operations help us in all of that. Time shifting was one operation we saw, right? So if xt occurs at a particular time instant, right? xt. So what happens to xt minus 3? It's delayed, right? Occurs later, 3 units later, yeah? xt plus 3 occurs earlier, yeah? What else did we do? और क्या operation थे?
वो इन्वर्स वाली की थी कि आगे अगर वो आ गया तो ऊपर से नीचे आ जाएगा.
दोनों एक्सेस से रिफ्लेक्शन देखी थी और
Time
स्ट्रेचिंग.
reversal की थी xt. If xt is like this, then x minus t is flipped, yeah? And minus xt is flipped like. आप मोबाइल में आता है ना, flip horizontal, flip vertical. They are applying those functions to your picture or whatever you have, right? So compression, right? Compression and expansion of the signal. Now somebody may have said among you, okay, what's the use of compression? But now you all are using it on your WhatsApp, right? 2x compression here, same content, but happening faster. Okay? So all those operations, sometimes they show up directly as in your WhatsApp. वो उसमें वही कर रहे हो पीछे जो उसके math होगा ना implemented. It's the same thing that you just saw. So, but then more importantly, these operations are like small units or atoms of the bigger operations that the systems do. Right? There are other operations, like clipping here, like magnifying here. There are many more. But at least we get started with a basic set, right? So a bigger system actually does a mixture of these, yes? And a digital system like this does much more than that, yeah? Or be add to that. But if you understand the principles that we are looking at now, you will be in a good position to understand the rest. फिर वो आपकी आगे studies, job पे है कि what you need, right? So we did signal operations, but with that we did something else also. We looked at 2 common signal models, right? The unit step and the delta function or the impulse, right? And we saw the sampling property of impulse, right? Very critical. If you are not comfortable with that formulation, you will suffer a lot in this course. We're going to use that over and over again. Yes, what was it? So basically it is saying if you have any function, let's say f of t, yes, and you multiply it with delta t with the unit impulse, what you get is, what do you get? It turns into a scaled impulse delta t f0. Yeah. Why is that?
नॉर्मल डेल्टा का 0 पर आपको दिखाई देता है.
Because if you look at this, we know that delta t is equal to 0 for t not equal to 0. Yes. Now in this product, any point where t is not 0, the value of f has become irrelevant. Why? Because it's being multiplied by a 0. Yes. So it's being multiplied by a 0 because of the delta function. F any value of this function at t not equal to 0 becomes irrelevant, so you drop it. The only value that is relevant is f0. Then why do you need delta t here? Because this is still a function. You also need to know where this f0 is going to occur. Now this is a constant. कोई fixed value है ना, 10, 0.5, 0.9. It doesn't have a time axis. So if you take away delta t, it will become a constant. It's not a function. You need to know where this 0.5 or this 10 or this f0 value, whatever that is, call it alpha, where does it occur? This guy will tell you. Now, what if I'm not interested in f0? What if I'm interested in f3?
डेल्टा 3 कर देंगे.
Yes. So ft delta t minus 3. Okay. Then what happened? Notice what you did. Did you shift delta? We studied time shift. Did you advance it or delay it? Delay. Why did you delay it? Because you wanted a later part of this. So you don't want f0. You want f3. जो कि बाद में आता है f0, right? So you wanted a later part of the function. Now, because of this property, this is a dummy variable. Yes, all it's saying is that delta box equals 0 for box not equal to 0. ठीक है ना? So if you place delta t minus 3 in the box, you're saying delta t minus 3 is equal to 0 for t minus 3 not equal to 0, meaning t not equal to 3. Right? So then this becomes f3, but what happens to this guy? Same. Again, this is now a constant. Yes? This is a constant, and so you can see the board later. I've been writing. So we started here. Ft delta t is f0 delta t. Discuss that because of this property. If you want another sample at any other value, you take delta t minus that value. Right? So t minus capital T, t minus k, whatever you want to call it. Here I just gave an example of f3. Now, because of this property, it becomes f3 delta t minus 3. This is a value. It's not a function. But now, when does this value occur? This guy is going to tell me. It occurs at t equals 3. Because if you plot it, वहाँ पे you'll get that impulse. Now, what if I'm interested now to go to the next step and extract this f3 from this function? कैसे किया था हमने? You integrate. Yes? What happens when you integrate these? Just look at the right. They are equal, so whichever side you work with is fine. This side is simpler. So
the constant as a value.
f3 is here, and remember we tried the dummy variable thing and it told us that the shift doesn't really matter, and this will still be 1. Area under this will be 1. Shift does not change this property as long as the integral covers the range of this thing. So this was 1. So basically integrating gives you the value of the function at this point, and this we call the sampling property of delta function. And that is the reason this function was defined and is being used. It gives you an elegant way of picking a sample from a function. So you have a function, you want the sample of the function at value k. So what you do, you multiply that function with delta t minus k, and you integrate, and you get fk. And now you're only interested in the sample, you're not interested in the time function, where does it occur or everything. Then you integrate it and you get that. Yes. So I'm emphasizing this because this will show up over and over again. We'll study linear time invariant systems. We will study some transforms, and this property of delta will show up again and again. Delta and another function which we will see today together, unit step इतना नहीं आएगा. शुरू में आएगा, then it's mostly gone. It's this guy and another function which we will study today, which will show up over and over again in this course. Okay, and if you are comfortable with what just happened here, then you're in a good shape. But you might be fooling yourself by thinking that if you look at it and yeah, it makes sense. No. Try several problems of the delta function. Right? There are many. Last time I gave you, like for example, I told you, okay, what's the integral of delta 3t, not t minus 3 times t. Yes? What's the integral, for example, if I ask you now, what's the integral of 4 to infinity delta t minus 3 dt? What is that?
0.
0. Yes? Why?
Limit is from
Does not include where the delta occurs, right? So you should be very comfortable with the properties of this function, how it behaves in the integral, how it behaves in a product, and the limits, how do they matter, if it is shifted, what happens, if it is compressed or expanded, what happens. ये चंद बातें, if you really lock them in your mind, memorization nahi hai. If you practice, you can mathematically see this. For example, this one, just plot it. What's the first thing they teach you about integral, other than it being the inverse of the derivative? It's the area. वापस चले जाएं उसको, right? So you are asking for the area from 4 to infinity of some function. Then draw the function. Now the function is delta t minus 3. That is, it occurs at t equals 3. Some delta occurs here. Now whatever happens here, without caring for that, we know for sure that there is no function here. This is 0. So 4 to infinity, 0. Yes? So like that, you should be able to work with the delta function. So we did unit step, we did delta function, and we did the sampling property of the delta function. That was very important. Now we move on. We are still in signals. We have been doing signal basics 1. What was signal basics 1? That was before. Yes? Good try. उसमें और भी थे ना, system भी था, transform भी था. After that we went to signal basics. What was the first thing we did? Signal basics.
Unit step.
Who we vocabulary? Classification. Yeah. So we classified. Then in signal basics 2, we operated on them. Right? Operations किए और फिर उनकी कुछ common. Now in signal basics 3, we're going to generalize the signals to include something else. I've mentioned that a little bit before, but we will see. So let's go too small. This much. So now we have to go to complex, and I know all of you love complex numbers, right? कहाँ देखें?
Sir,
Circuit analysis.
calculus में देखिए circuit
Calculus, circuit analysis.
Two.
When I was a student here, we used to have complex numbers and transform techniques as a core course. I think it was removed at some point. These days, EE and some other faculties are taking it. We teach it at any sciences. I don't know, I think in the new curriculum I may have added it again. But it's a very important course. Anyway, in this course, we will not cover all the details. I will only talk about the parts that we need for this course. Complex number theory, complex functions, वो पूरा एक domain है ना बड़ी. So we need some parts of it. What we have discussed so far can be classified as real. Yes, real signals, say real operations. So now we are going to do a bit of complex signals. So before complex signals, we need a bit of revision from complex numbers. Yes, and what are complex numbers? I think this is Kelvin and Hobbes. Yes. So it's the imaginary numbers 17, 30, 12. Yeah. So what are complex numbers? You know this line, real number line. Yes. So all the real numbers you know fall on this line. Yes. But then what happens if we want to get complex numbers? From line you go to two lines.
You make a plane.
Plane. Yes. So you go from a line to a plane. Yes. Now all the real numbers fall on this line. Yeah. And the modulus of those numbers on this line, what does that tell you?
Magnitude.
Yeah, but what is magnitude? Let's say on the real number line. If I take the all the real numbers fall on this line. If I take the modulus of a real number, what does that tell me?
Range or distance?
Distance from what? From
What is it?
0. So you're checking its size.
Is that necessary to zero?
Distance from 0. So let's say 4. Yes, 4 is a real number. What's the modulus of 4? 4. Because it is 4 units from 0. Its length क्या है? 4. What's the modulus of minus 4? 4. Why? Because it is 4 units. Yes? It doesn't care about the direction. Yes? So we will see something like that here also. So we go into complex numbers. You add a new axis, and all of a sudden now you are dealing with the plane. What's this axis called?
Imaginary axis.
Imagine. Yes. So in physics and math, often they use I. In engineering, we use J. Yeah. So what is the imaginary axis? So a number falling on this line is purely imaginary. Its real part is
Not present there.
0. Yeah, 0 plus 3j. Whereas the number falling on the real line, its imaginary part is
0.
0. Yes. So, and a number that has both of these, normally we call it a complex number. Yeah. Okay. So where do complex numbers fall? So imaginary fall on this line, real fall on this line. Where are complex numbers? Of course, each of those are subset of complex numbers, special cases, but general complex number, they fall in this plane. उनका किसी कोई point होगा ना, right? Okay, so they would fall on a point. How can you uniquely identify a point in a plane? कैसे कर सकते हैं?
You write its coordinates or maybe.
Coordinates are one way. Coordinates always assume that there is some origin. Yes, so you take 0, 0 is your origin. So what coordinates can you write to uniquely identify a point on a plane? If you have decided the origin, yeah. So क्या coordinates करते हैं?
2 Cartesian coordinates, you could do polar coordinates, you could do.
Exactly. So you could try, say, you could tell me, okay, from the origin, go x units to the right, and then y units up or down, whichever, right, left, and you are here. That is a very unique position. Another way is to say, okay, from the origin, turn yourself until you are looking at this angle, 45 degrees, and then walk 5 steps. That's also unique. But both of them could lead to the same point if you decide make them properly. So it turns out that in the complex plane there are at least 2 ways to uniquely identify a point, and you have studied those, the Cartesian coordinates and the polar coordinates. and of course the two are related. You can convert one into the other. If you know polar coordinates, you can tell us the Cartesian. And depending on the problem, in some cases it's better to work with Cartesian, in other cases it is better to work with polar. But this is just a quick revision. By the way, why do we need complex numbers?
There is one
You like
application.
complexity?
There is, the world is complex, you could say one that, but the good application for it.
You know, in the real world there is no complex number.
Yeah,
You can
there is.
have one apple or two apples. You can't have 3 plus 4j apples. Even atoms,
I think
है
a
कोई
good
नहीं?
reason for it is because you can see the application in circuit analysis too, where they separate the the normal resistance and your basically impedance. I think basically the AC component. Basically they separate these two components, but they want to show it together. So they basically can say that one is real and one is imaginary.
Okay. Any other reasons? There are multiple reasons, of course.
Multiple dimensions.
So, firstly, yes, where a real number stores information about one quantity, yes, an imaginary number can store information about two quantities, could be magnitude and phase of the signal or the current. So it's our mathematical way of storing more information, right, about some process, some point, some event. You collect two related information in one point. Usually it is the angle, the phase of that, and then the magnitude. Another mathematical reason is the fundamental theorem of algebra. पता है उसका? ये जो uses है ना हमारे ज़हन में, current वगैरह, this was किसने किया था ये? Greeks का time में. उस वक्त ये चीज़ें नहीं थी. This is something that became practically useful many centuries later, right? But उससे पहले इनका एक analytical use था, जहाँ से ये निकली है. वो क्या था? That's related to the fundamental theorem of algebra. क्या है fundamental theorem of algebra? नाम से तो बड़ा fundamental लगता है, और algebra तो आप बचपन से पढ़ते आ रहे हैं. So you would know.
So ये वो चीज़ तो नहीं है जो -1 का आप वो ले लेते हो अंडर रूट इक्वल टू आई होता है.
वो तो definition होगी ना.
वो तो आयोटा होता है.
Complex जो unit complex value या imaginary values की definition होगी, right? So where does it come from? Or what is the fundamental theorem of algebra?
याद नहीं आ रहा.
नहीं याद, but you know it in some other way. It's that an nth order equation has how many solutions?
And it's solution.
How many? N. Yes. So a quadratic equation has two solutions. Third order equation has 3 solutions. Now for this assertion to hold, you need imaginary numbers. If you take away imaginary number from our toolbox, many quadratic equations will only have one solution. Yes, many will not have any solution. You go conjugate pair, उनका solution होता है, complex conjugate pair. So it's actually an elegant way of also dealing analytically with equations, with polynomials. Okay. Now you can simply say an nth order equation has n solution. Some of them will be real, some of them will be imaginary. Yes. So इसीलिए जो स्क्वायर रूट -1 है वो फौरन निकल आता है. कहाँ से निकलता है? x square plus 1 equals 0. You give me this equation, I have to solve it. Take away imaginary numbers, I have no solution, right? But then you allow me imaginary numbers and I say okay, it is square root -1, so plus minus iota is the answer. So bit of digression there. This is a complex number. It is a point in a plane. Yes, you can say okay, along along x-axis you go this much, along y-axis you go this much. Then how do we denote this? We say okay, z is a plus jb. Now if you read the complex number next time 3 plus 4y, read it as a map. Yes, one piece देख रहे हैं आजकल?
Yes.
मैंने खत्म
No,
कर
no,
दिया।
सर
तक अभी तक चल रहा है ना।
सर उसकी नेटफ्लिक्स एडेप्टेशन सरप्राइजिंगली अच्छी थी सर, लाइव एडेप्टेशन मैं सोच रहा था काफी नीचे जाएगा, मगर सर एनिमे से फिर भी बेहतर नहीं है वो
मैं देखा नहीं होगा। Right.
So
So what
live
I've
action
seen
देखा
नहीं है,
आपने?
yeah.
Live action.
So they have maps there, right?
Yes, sir.
Maps right. So 3 plus 4j is a map. It's telling you how to get to this complex number. Go 3 steps this way, 4 steps this way, and you are at that number. Yes. So this length we often call it r. Yes, radius. So can somebody tell me what is the length of z, which is r? क्या formula होगा इसका?
Modulus
Modulus of
A square plus b square whole root.
A square plus B square.
square root of a square plus b square. Simply आप किसका थ्योरम यूज कर रहे हैं? पिथागोरस का. Yes. यूक्लिड की ज्योमेट्री में पिथागोरस का थ्योरम यूज कर रहे हैं आप. Yeah, great guys. So now that's why the modulus is defined like that. कोई मैजिकल नहीं है उसमें. और इसीलिए जो मॉड्यूलस फॉर रियल नंबर्स इट जस्ट बिकम्स इट टर्न्स माइनस इनटू प्लस. रियल नंबर्स बेचारे का कोई काम ही नहीं बचता सिवाय लेंथ बताने के. राइट. इफ इट इज -4 इट ओनली केयर्स अबाउट द लेंथ नॉट द डायरेक्शन. डायरेक्शन को वो उड़ा देता है. सो इट सेज 4. हियर it's a bit more complicated because there are different directions. So yes, and this r is very important often. As I said, this will be used in the polar coordinates now. Okay, so what is the angle of z? Theta.
Tan
Yes,
inverse
so
B upon A.
tan inverse
B upon A.
yes. तो बेसिकली जो आपने ट्राइगोनोमेट्री दो के पढ़ी है किसी टाइम पे राइट उससे इट्स वेरी सिंपल टू find out that the angle is tan inverse b upon a. But notice you just found the length, the radius in terms of the Cartesian coordinates, and you also found the angle in terms of the Cartesian coordinates. If you know b and a, you can find r and you can find theta. But as I said, another way of reading this map is to tell someone that stand at the origin, then turn theta radians, and then go r units in that direction, and you will reach the exact same point. Yes, so it's another map, and of course that means now the reverse or the converse can also be done. What if you know r and theta? Can you find a and b?
Yes, yes.
Again, trigonometry, basic projections. If you know r and theta, then a and b are simply projections of r onto real axis and imaginary axis. So both are completely interchangeable, and of course we can write, if you have the map a plus jb, you can write it r cos theta plus jr sin theta. Now this doesn't look like a very nice description, right? So what can we do about it?
Euler's transform.
Euler's, yes. So now और scientists, mathematician jump in करते जा रहे हैं इस plane में. Yes. So we started Euclid, Pythagoras. Now Euler is in there. And what would Euler do here? He would say Ej theta is cos theta plus j sin theta. ये पता है Euler's identity? Yes. क्या है ये? Ej theta cos theta plus j sin theta. ये बहुत elegant identity है ये. Yes. Arguably, many mathematicians say, if you ask them what's the most beautiful equation in mathematics. Now, firstly, these two words in one sentence can be very annoying. Beautiful and mathematics. Yes, for many people. But if you are really into it, you will see many of them say the most beautiful equation in mathematics, you write it in two ways, but it is E iota pi minus 1 equals 0. Okay, because it contains so many important constants of mathematics, right? Imaginary numbers का जो unit है वो यहाँ पे है, transcendental numbers का E यहाँ पे है, irrational numbers का pi यहाँ पे है, फिर आपके पास जो one है unit. It took people a lot of time to come up with this. 0. A lot of mathematics 3000 years ago had no 0. Yes. Then the Indians came up with shunya, that cipher. Yeah. उससे math revolution है. Amazing सी बात है. है? शून्य नहीं होता सिफर. Yeah. So this equation alone contains so many leaps in human history. Yeah. So it contains a lot of information about these kind of numbers, and many of them took humans centuries to discover, or let's say invent. Some people say maths is invented, others say math is discovered. It's बहस है, ये चलती रहेगी. यही वजह है कि मैथ को ऑफिशियली साइंसेस में नहीं गिना जाता, राइट? मैथमेटिक्स एंड साइंसेस लिखा जाता. इसकी वजह है बिकॉज देयर आर आर्ग्यूमेंट्स दैट मैथमेटिक्स इज अ कंस्ट्रक्शन. सम अदर सिविलाइजेशन मे कंस्ट्रक्ट इट डिफरेंटली फॉर द सेम यूनिवर्स. सो इट्स नॉट रियली नोन कि ये डिस्कवरी है या जो भी है. सो back to this, because this is linked to Euler's identity. So what does Euler do to us? Then it gives us the polar coordinates or the polar representation. Yes. Now this is the polar representation. ये तो देखिए आपने, but E J theta इसलिए आता है. Yes. Now here you are interested, of course, in R and theta, but the full expression is R E J theta. There compared to what? Z equals A plus J B. वो क्या था? Cartesian. This is polar. Yeah. So there you add, yes, real part, complex part. Here you multiply R with E J theta. Now you know the story behind this, back story of this guy. Yeah. So another operation that often comes in handy in working with complex numbers is the complex conjugate. Yes. What does the complex conjugate do? It simply replaces J with minus J. What effect does it have? You can convince yourself very easily that in both cases, Cartesian or polar, replacing J with minus J would flip it to the lower. हो जाएगा ना उसका? It's just a flipping, a flipped version, and it comes in handy. The Z star comes in handy, right? So what's the complex conjugate of a real number?
It's the same thing.
Same. Nothing to flip. Hey, real number line है ना? So you are there. You need to flip the complex part. इसमें होता ही नहीं है. So that's it. Right. So summary, this is what you have: real x's, imaginary x's. You can write so many different. You can write projections. You can write distances. You can write. You can convert one into the other. सारा कुछ यहाँ पे आ गया. Or you have studied this before. So this is not really my topic. We have to go to the next one where we will. This is the guy we are interested in, this EJ theta guy. ये हमें हमारे interest का असल में. But you cannot understand that without recalling all of this history. Some interesting results. I want you to take paper, pencil, and answer these सबका जवाब दे।
सर पहले का तो Z आएगा।
ठीक है।
ये होगा
थर्ड फर्स्ट का Z क्यों आएगा?
रियल
the conjugate.
Z है, Z I represent Z means complex number. Okay, so you can assume that. Why is
जी
it?
आएगा क्योंकि एक बार कॉम्प्लेक्स उसका फिर दोबारा कॉन्जुगेट लेंगे, दो बार कॉन्जुगेट लेंगे।
एक बार उसको निगेट किया फिर निगेट किया, यानी फ्लिप ऐसे किया फिर फ्लिप ऑफ।
पॉजिटिव
So Z conjugate is Z.
यस
What about Z conjugate?
सर माइनस वो
हाँ?
Real number आता है।
लेकिन क्या होगा?
एग्जैक्ट
करके देखें, जल्दी से कुछ ट्राई करें।
करके देख रहे
आप ग्रीक मोड में चले जाते हैं, रोमन मोड में जाते हैं, रोमन मोड। पहले ये हम यूज मैथ ग्रीक वालों का यूज कर रहे हैं, लेकिन रोमन मोड चाहिए था। सो जल्दी से जी स्टार्ट कैसे करेंगे? स्टार्ट कैसे करेंगे? सोचने के अलावा देख घूरने से वो ठीक नहीं रहेगा। Where would you start?
सर पहले वो कॉन्जुगेट से स्टार्ट करेंगे, वो जो
और
स्टार्ट
लेंगे कैसे? हाँ,
उसके बाद फिर मल्टीप्लाई कर लेंगे उसे,
किसको? जी
कॉन्जुगेट को सादे जी से मल्टीप्लाई।
पहले जी क्या होगा?
जी कोई रैंडम अज्यूम करेंगे कोई
एज्यूम कुछ भी कर लें। कौन से कार्टेशियन में करना चाहते हैं या ठीक है?
सर ऐसे तो रिजल्ट नहीं बता सकते ना, मतलब वो तो कोई भी नंबर हो सकता है।
नहीं, जनरल क्यों नहीं कहते? आप मैथ नहीं पढ़ते, एनालिटिकल क्या हो गया? एक्स स्क्वायर
A square plus B square.
रियल का स्क्वायर भी है।
रियल में नहीं होता अपना उसको तो कॉम्प्लेक्स हो जाता है आई का स्क्वायर
सो किसी और ने निकाला?
जब
आप क्वाड्रेटिक इक्वेशन का करते हैं, एक्स स्क्वायर प्लस बी एक्स प्लस सी इक्वल 0 निकालते हैं ना, उसका रूट्स निकालते हैं, एनालिटिकल रूट्स हैं, कोई वैल्यूज तो नहीं दी हुई, इसका भी निकाल सकते हैं। जी स्टार्ट क्या होगा? स्टार्ट कहाँ से करेंगे? पुट z in its general form, either use Cartesian or use polar, जो आपको पसंद है। कार्टेशियन में z लिखें तो कैसे लिखेंगे?
A plus B G.
राइट? अगर तो फिर जी स्टार क्या होगा उस केस में? उसको बस मल्टीप्लाई करेंगे, क्या प्लस बी, राइट? सो जी स्टार इज a square plus b square. Yes. So what is the square root of a square plus b square?
सर ये तो
वही
A
Z
minus
मॉडुलस है।
मॉड्यूलस का स्क्वायर
आर
आप
है, आर
हाँ मॉडुलस का स्क्वायर
आई थिंक आर
सही
Yeah,
है।
that is R. So what you got is z star, which is not really the modulus of z, because the modulus of z is square root of a square plus b square. You're getting the square of that. So okay. Z star. So a complex number multiplied by its conjugate gives you the modulus squared. That is one of the most common analytical uses of the conjugate. Or notice, is this a complex number or a real number? Real number. So often it helps us bring the problem into real numbers. Okay? So
इसी को आप थोड़ा वैसे कर सकते हैं, z इक्वल्स टू a प्लस b आयोटा करके उसको
yeah, sure. So you have z is equal to a plus jb, and this is a minus jb. A times a square. So this is a plus b into a minus b basically. उसका आता है फॉर्मूला? a plus b into a minus b क्या होता है? a square minus b square. A plus b into a minus b. Yes. So a square minus j square b square. Right? What is j square? Minus. So it is a square plus b square. Or if you see the square root, that is absolute of z. But you got without the square root. So you get modulus of z square. Yes?
तो बस हल्का सा ऑफ टॉपिक सवाल है। हम जब पहले मैथ करते थे तो जब हम आई में करते थे ना, लिखते थे तो a प्लस बी आई लिखते थे।
हाँ
जब इंजीनियरिंग में आया ना मैंने गौर किया कि ए प्लस जे भी लिखा जाता था पीछे, तो ये बस वैसे स्टैंडर्ड का फर्क है या वैसे दिल का
हाँ, ये बस कन्वेंशन का है, इसमें कोई
यूनिवर्सिटी लेवल पे प्यारा लगता है मुझे।
क्योंकि मैं
एक दफ़ा मैंने I read long ago, I don't remember, there were some issues with I in engineering, computing में कोई issue था, I don't remember, लेकिन अच्छा है, it can be searched origins अगर मिल जाता है इसका कोई, right? But yes, we and then they didn't actually use I, you know, iota use करते थे वो Greek letter, which would be harder to make on older computers, I suspect. तो with time वो engineering में J पे आ गया. Okay, so what about the third one?
सर ये एक छोटा सवाल था, ये जे आपने किधर निगेट कर दिया? ये जो पीछे है।
नेगेटिव
अब जे स्क्वायर माइनस 1।
अच्छा वो आयोटा है ना पीछे से। समझ आ गया।
J is square root of minus 1 तो square root of minus 1 is minus 1, so सारा कुछ complex number थोड़ा सा दिमाग के
इसका
साथ.
आंसर 1 है।
इसका आंसर 1 है. क्यों भाई? दिल चाह रहा है?
cos स्क्वायर प्लस sin स्क्वायर आपका 1 इक्वल होगा।
Good. So Ej theta is cos theta plus j sin theta. We already saw that the modulus means take the square of the real part plus the square of the imaginary part without the j, of course, and square root. Yes. So cos square plus theta, cos square theta plus sin square theta square root is of course 1. Yeah. So yeah. Last one. N is any integer.
Sir 2 1।
2n. Okay.
स्पीड
Accuracy.
इसका तो जे दिया था,
Speed है.
डिटरमाइन क्या
जे
करना
दिया था जे स्क्वायर।
ऊपर वाले की बात करें. हाँ.
सर 2 1 नहीं
हाँ,
है,
जे
सिर्फ
स्क्वायर
n है।
नहीं जे नहीं वो सर
तो नहीं है,
आ गया ना.
तो ये वन के बराबर नहीं।
1 के बराबर cos स्क्वायर।
इसका स्क्वायर उठाया ना, ठीक है. ठीक है.
रियल
First,
नंबर
know this that a plus jb modulus is, we have been saying, it's the square root of the real part plus many, right? Now for ej theta, what's the real part? Cos theta, Euler identity लिख दें, plus j sin theta. You want absolute of that. Square root the real part plus square root the, हाँ ठीक है. हाँ वो सही है. This is, ये जो आप कह रहे हैं ना, समझ आ गई. ये आपने ट्राई किया है और अब क्लियर हो गया. अगर आपने ट्राई ना किया होता है ना, आई कैन बेट कि आप गलत करते हो.
सर आंसर इसका n है।
सो इट्स वेरी इंपॉर्टेंट टू प्लीज ट्राई ऑन योर ओन. डोंट, अगर आपके कॉलीग्स कह रहे हैं सारे कि हाँ ये जवाब है, डोंट रिलाई ऑन दैट. खुद करें, तब आपको होता हुआ नजर आएगा. वो गलती करेंगे, फिर ठीक होगा, फिर वो लॉक होगा. ओके. उसके बाद भी थोड़ी फिर आपको स्पीड बढ़ानी है. उसके लिए यू नीड टू सॉल्व प्रॉब्लम. अभी क्लियर हो गया है, पर इतना नहीं कि आप फॉरन एग्जाम में सॉल्व करते हैं, वहाँ फिर आप गलती करेंगे.
1 ऑफ द आंसर
फॉर एनी इंटीजर
1
n
n है, 1 है. वोटिंग करा लें या और भी कोई?
सर वोटिंग में सॉल्व करो n।
करेंगे. हाँ. इसलिए तो आया सॉल्व करने.
ये मैंने भी देखा था कल।
इंशाल्लाह कल नौकरी को यूट्यूब में देखिए।
अभी अपने चैनल पे अपलोड कर देगा. वॉच माय लेक्चर.
Watch my lecture.
जवाब आपका गलत है भाई. लेकिन जस्ट फॉर द रिकॉर्ड.
सर मैं
यूट्यूब
सर मैं ट्राई करूँ.
ये 0 हो जाएगा
अगर
तो ये
थीटा
1 हो
काम
जाएगा।
करेगा ना वो जो भी
अब ये आपका n जो है वो r के इक्वल है।
किस तरह किया आपने? सो
सर इसमें
सर मैं ट्राई करूँ.
पर इनका देख लेते हैं ना. So you need EJ 2 pi n. So what would be EJ 2 pi n अगर आप इस तरह लिखें?
सर ये 2 पाई हमारा एंगल n हमारा r की वैल्यू.
Why? EJ theta is r cos theta plus j sin theta. By that, what is theta here?
अच्छा फिर बंद होगा.
हो गया. इसे भी निकल आएगा लेकिन जाहिर है. देखिए, you have to map things. Basic algebra. If you are mapping EJ theta onto this thing, then E is already here, J is already here, then theta maps to 2 pi n, nothing else. Many of you make these mistakes in the exam. Mapping आप गलत करते हैं. I don't know, वो practice की, right? So always don't be in a hurry. Tell yourself, because mapping, if you start with the wrong mapping, what happens? Everything else goes wrong, right? Even in many cases, students do the wrong mapping in a problem, and they end up with some very complex kind of integrals, and then they tell me, "Sir, आपने तो इतने मुश्किल integral दिए हुए थे." थे ही नहीं उसमें. 1 जवाब था, 0 जवाब था, right? So मैंने तो नहीं दिया. You do the wrong mapping in many cases, right? So what is good? As soon as you do the right mapping, you see the answer. And it's usually very simple. Okay, good try. And
So Euler identity लगाकर वो
उससे भी हो जाएगा.
उसी से मैं निकाला.
उससे भी हो जाएगा. Many different ways of doing it. So good. Yeah, so you got all the answers right. And got. So this one you have. Now I've put some examples here just to show you that as a general rule, by the way, addition and subtraction of complex numbers is easier in Cartesian. Multiplication and division of complex numbers is easier in polar. This is what I want to show you here. You can try, but I have the answer. If you do the multiplication in Cartesian, you have to multiply 3 with 2, then सारे pairs निकालें. But look at the multiplication in polar form. You know what happens? The modulus is just multiply, right? 5 times square root 13, that's it.
तो कार्टेशियन के साथ ज़्यादा नहीं है ना, तो मल्टीप्लिकेशन जब करते हैं कॉम्प्लेक्स नंबर्स
एक काम
सर्किट में निकल कर चुका है.
एक काम करना, कैलकुलेटर में जो हम इस्तेमाल करते हैं ना सर्किट 2 में कॉम्प्लेक्स मोड, वो इस्तेमाल करो, आसानी से सब कुछ कर देना.
कर तो सब कुछ देता है. But I'm just showing you here that if you do this product in a polar form, it's much easier because then you just multiply R1 with R2, and angle का क्या करते हैं?
प्लस कर दो.
That's it. Right? So becomes easier. In division again becomes a headache. देखिएगा division का क्या हो रहा है. But notice something I mentioned. They use the conjugate. ठीक है? ये सारी चीजें एनालिटिकल कामों के लिए निकली हैं. शोकिया नहीं बनाएगी डेफिनेशन. They have origins in solving things. But look at the polar form. कुछ भी नहीं है. R1 divided by R2. जो पहले का जो मॉडुलस है R1 कह रहा हूँ उसको. और एंगल क्या हो जाएगा? सिंपली माइनस हो जाएगा. आता है ना आप लोगों को?
फॉर्मूला से.
हाँ, xn over xm क्या होता है? xn minus m. Right. सही कह रहे हैं. So similarly, you can try this. So we will skip it. ये जल्दी से करें, बताएं मुझे इसका आंसर.
कैलकुलेटर अलाउड होगा.
हाँ. पर अगर आप बहुत बेसिक सी चीज़ करने के लिए कैलकुलेटर यूज़ कर रहे हैं और वो आपसे गलत यूज़ हो जाता है, फिर वो आपका मसला है. वो अक्सर दिखाते हैं, मीम सा आता है ना, जो रात को आँख खुलती है याद आता है कार्टेशियन पे सेट हुआ है, रेडियंस पे सेट हुआ, फिर वो आपका मसला है. सो डोंट ओवरकिल विद कैलकुलेटर. ओके, मेरी कोशिश होती है एग्जाम ऐसा हो कि आपको कैलकुलेटर यूज़ ना करना. I want to check your understandings mostly. But yeah, you're allowed. Yeah. तो जैसे कैलकुलेटर पे कर रहे हो एक दफा तो कर लो. क्या है जवाब? वैसे बता दो. Z1 over Z2 square. Z2 का एब्सोल्यूट स्क्वायर नहीं है, स्क्वायर है.
नहीं, क्या मतलब से पूरे पे ही आएगा. जीरो पूरे पे आएगा, कंप्लीट पे आएगा. 8 चेंज होगा.
हाँ, लाइक एक तो होता है ना, हम कहते हैं मॉड्यूलस स्क्वायर करते हैं ना, वो नहीं है. It's g2 square, simple square.
Plus 5 by 10.
Oh, five.
ये power is -5 by 12.
मिल के ले हो गए हाथ से.
सर मैं
It's very easy, right?
यही है.
So firstly you have 2 ej pi by 4, that is 8 ej pi by 3 square, so 8 becomes 64, j 2 pi power का वो product हो जाता है, yes, so it's become ej 2 pi by 3 and वो simply आप subtract कर देते हैं powers और 1 by 32 will do this, right? So this is what you get. So I will give a quick trailer of what's coming and we'll see, maybe we do a bit of it. A sine and a cosine, you know, jokes, बार वाले jokes होते हैं. There series of jokes बड़े अच्छे होते हैं जो top class के होते हैं. एक वो walk in a bar वाला होता है, एक कौन सा है, बल्ब वाला, पता है आपको?
कौन सा?
बल्ब वाला.
दूसरा बल्ब वाला.
वो पढ़े जाओगे, बहुत आपने भी बना सकते हैं. They say how many theoretical phases does it take to change a bulb? कितने theoretical phases चाहिए? So 2. One will hold the bulb, the other will rotate the universe.
So
Okay, इस तरह लोगों ने citizen nationalities पे भी बनाए होते हैं. बल्ब वाले तो बहुत
सर ये तो
लंबे.
वो ड्रंक जोक्स मुझे लग रहे हैं सर. बार में ही बैठ के जो ड्रंक नहीं हो जाते फिर ये उस टाइप के जोक्स लग
Up
रहे
to
हैं.
you, मतलब ठीक है, आप इस बहाने से वो लाना चाहते हैं अंदर से आए. लेकिन another group is the knock jokes, right? बच्चों के साथ जो knock दिया.
Who's there?
But this one is a sign. So walk into a bar बड़े अच्छे interesting होते हैं. Here we are of course interested in an imaginary bar. Notice this is the function that I was talking about. इसका भी actually थोड़ा सा और advanced version आएगा आगे. लेकिन this is where it starts. So on one end there is the impulse, बहुत critical, and the other end there is this guy, the complex sinusoid, and its further generalized version which we call the complex exponential. Okay? So now the complex sinusoid, you already know it. By Euler's identity, what is it? E j omega t is?
cos omega t plus j sin omega t.
So then you know that a complex sinusoid is a function whose real part is cosine and whose imaginary part is sine, right? So these are its, a sine and a cosine go into this imaginary bar and they turn into, if you put them with a j here, they turn into e j omega t. Yes. Now these two are real planes. Yeah. So what is happening? The real part is following over time. There is a t here. With time, the real part is following the cosine function, and the imaginary part is following the sine function. If you want to see it in the complex plane, how does e j omega t look in the complex plane? It is a function, right? Firstly, it forms a circle. Can you tell me why? Circle क्यों है? Oval क्यों नहीं है? Spiral क्यों नहीं है?
सर ये आई थिंक वो होता है,
एंगल का वो है.
आपका जो R होता है ना,
One ही होता है.
बेसिक थीटा आप चेंज कर रहे हैं
Yes.
360 में, आपका जो समेशन R होगी ना वो आई गेस
Summation
वो
है ही
सेम
ना?
R सेम रहेगा
Same.
और थीटा आप चेंज करते
And what is R in e j omega t?
-1.
पता नहीं क्या है वो, आप पता है.
1.
-1.
1. ये माइनस ही लिखा और डैश दिया. So what did we say was the polar representation of a complex number? It was r e j theta. Now we have replaced theta with a time varying angle which we are calling omega t. Yes, ये time variation है जो इसमें ये animation ला रही है, movement ला रही है. So otherwise तो कोई एक point निकलता है ना. Yeah. So you have r e j omega t. Yes, but notice if we are talking about e j omega t, we have only replaced theta with omega t. Then r is not here, but something is here. It's a 1. Yes. So e omega t always has modulus 1. ये आपने किया भी है पीछे. Modulus of e j theta was 1. You found it, right? So of course it's going to make a circle of unit radius. If you wanted to make a circle of radius 2, what do you need to do?
2 से multiply.
2 से multiply कर दो. 2 e j, then r is 2. Yes. Now why is it turning like that? Because your angle is now a function of time. With what frequency is this angle changing? Omega. Radians में है ये. Yeah. If you want it in hertz, 2 pi f is omega by 2 pi f, so f will be omega by 2 pi. Right. So in the complex plane, it looks like a unit circle, and because of the time variation of the angle, theta is omega t. Omega is a constant, but t is time. So over time, the angle is changing. So it's tracing a circle. But as in the polar coordinate, your e j omega t traces a circle at every point. Its projection on the real axis traces cosine, and its projection on the complex axis, the imaginary axis, traces a sine. So this is the breakdown. Now what's happening here? Here we show time by animation, right? Animate kar diya na, so the time factor aa gaya. But what if I don't have that luxury? Then this is what it would look like. Yes.
इसकी कोई समझ नहीं है
अब ये एक x हमने टाइम का एक्सिस दे दिया.
सर वो पीछे वाला ज़्यादा प्यारा
Right. Now what's happening two ways. Either you look at this vector e j omega t. हर वक्त उसकी size क्या है उसका? 1 है. Yes. So its size is 1, r is 1, angle is changing, and with time if you plot that, it's going like this. Yes. Now if you want to draw a trace of its tip, ये तो पूरा एंगल बनाया है, पूरा वेक्टर बनाया है. जैसे उसके टिप को ट्रेस करें विद टाइम, तो इट बिकम्स ए हेलिक्स. यस, बाहर को आ रहा है ऐसे हेलिक्स, फिक्स्ड रेडियस का. यस, रेडियस चेंज नहीं हो रहा. If you throw a light on the helix from this angle, project it onto the imaginary axis, उस helix का projection क्या बनेगा? Sine function. If you throw light from above, will get its projection on the real axis, वो क्या बनेगी? Cosine function. And if you look at it from the front, तो आपको वो जो पीछे नहीं सर्कल ऐसी नजर आएगा, वही जो आप कह रहे पहले वाला अच्छा था, ये चीज ये नजर आएगी. Right? So why am I showing you this? देखिए, graphical understanding of mathematical functions is really key to doing well analytically. Okay, बहुत सी चीज़ें आपके लिए आसान होती जाती है with time. So I don't want you to just see j omega t. I want you to see this or this happening with that. So ये next time कर लें, ठीक है. Right. So attendance and let's close this. By the way, any questions?
No, sir.
No? Stop.